So I have the differential equation y prime minus y is equal to e to the 3t. And I have the initial condition y of 0 is equal to 1. I want to solve this differential equation using the Laplace transform. So I take the Laplace transform of both sides. The Laplace transform of y prime is s times capital Y minus y of 0, and the Laplace transform of minus y is minus capital Y of s. And the Laplace transform of e to the 3t is 1 over s minus 3. So now I solve for capital Y. I get that capital Y of s is equal to 1 over s minus 3 times s minus 1. Plus 1 over s minus 1. And so now I can do partial fraction decomposition. I can write this 1 over s minus 3 times s minus 1 as a over s minus 3 plus plus b over s minus 1. So this is my partial fraction decomposition of this 1 over s minus 3 times s minus 1. And so now I can solve it, and I get that a is equal to a half and b is equal to negative a half. And so I still have my 1 over s minus 1 here. So I have a half of 1 over s minus 3 minus a half of 1 minus a half of 1 over s minus 1 plus 1 over s minus 1. So I have minus a half plus a half because those are the same expressions. And so I get plus a half. So I get a half of 1 over s minus 3 plus a half of 1 over s minus 1. And so I can factor out 1 over 2. Yes, and so now I can take the inverse Laplace transform of 1 over s minus 3 and 1 over s minus 1, and I get that so the inverse Laplace transform of 1 over s minus 3 is e to the 3t as at the beginning, basically, and the inverse Laplace transform of 1 over s minus 1 is simply e to the t. And so I can factor out the e to the t, and I have at the end that y is equal to 1 half e to the t times, in parentheses, e to the 2t plus 1. That is my final result.